Telecom technologies. So today we are going to discuss about introduction of technologies. Now, as telecommunication is communicating over a long distance, and this telecommunication, like we have wireless. Over a long distance, we can have wired, but that requires a dedicated connection between the two ends. So we prefer wireless communication over a long distance. We call it as a telecommunication. So as per the wireless technologies, we have various generations. Like we started from the very first as 1G, which is the first generation of wireless technologies. We call it as telecom or telecommunications. So 1G has started the era, that means from 1G we have started wireless communication between one end to another end. So first generation has technologies like we have NMT, which is Nordic Mobile Telephony. We have TAX, which is Total Access Communication System. Then we have ETAX, which is European Total Access Communication System. That means they started to have wireless communication between two ends. So they call it as this is the first generation of a wireless technology. Now in this 1G, what they prefer? They prefer analog signals. That means all processing of analog signal, like I am speaking, so the waveform which I am radiating is an analog signal. It is not being converted into the digital one because that is another era. So 1G is uses analog system, analog signals. Now, as we know the disadvantage of analog signal, that means they are not able to cover up the long distance. So we have the 1G generation. After that, we have to move to the digital era. So for digital era, we have second generation. That means 2G is a digital technology. It uses digital technology and the signals which it uses as digital signals. That means they have converted analog signals to the digital one and digital to analog one. So because digital signals are able to cover up a long distance, that's why we have used a digital signal in a second generation. Now for second generation, we have the technology as GSM. Now when it was discovered, its name is Group A Special Module. And after that, when it was globally accepted, so its name changed to Global System for Mobile Communication. Because it became a global standard, it became a global system and globalized. So its name is Global System for Mobile Communication, and it is the very successful technology in the second generation for having voice communication. So our dream, that means to communicate over a long distance, it is possible because of the GSM technology. Now we are communicating on 2G network and 2G voice. That means we are using GSM technology and it is globally accepted for wireless voice communication with the name as GSM technology. Now GSM is the very first technology in the second generation. Now after that, after voice, our main aim is data. That means what we require from a server end, we require data access. So we move to another technology, we call it as that this is our 2.5G. So we call the technology as GPRS. So GPRS stands for General Packet radio service. Now here we have radio service. Radio means air. That means packet transmission through air interface. No dedicated connection here in this case also. That means no use of LAN wire directly to the computer and accessing internet. We have to access internet through air. Air as a radio service. So 2.5G is a general packet radio service. But the data rate here in this GPRS is very less. So we require to have more data rate. So we have 2.75G, called it as 2.75G with the name as Edge. Edge. Now E stands for enhanced data rate for GSM evolution. That means we have increased the data rate. From GPRS, we have increased the data rate in edge technology. When we access GPRS in our mobile device, we have sign as G. When we access edge, we have sign like E. So combinedly, these all in under, that means 2G, 2.5G, we call it as, this is our second generation. So when we have second generation in a handset, we have nowadays for voice, we have GSM technology. For data, we have edge technology. So this is what our 2G is, and these are the technologies under second generation. But data rate here in this case also not that much good because we require to evolve, we require to increase data rates. Evolution of voices with GSM, but after that we have a main evolution of increase in the data rates. So then we have 3G. 3G with the name of UMTS. UMTS stands for Universal Mobile Terrestrial or Telecommunications System. UMTS gives us a data rate of 384 kbps. Whereas earlier for Edge we have around 170 kbps, and for GPRS we have 56 to 64 kbps. That means now we can see that there is an increase in data rate what we require in our new generations. So basically UMTS, which is a 3G, and this is also having a feature of video calling. Because what we require, we have a voice calling now, we have smartphones, we can have video calling also that require more data rate that is offered by 3G. Now we have set up a target, like whenever we have 1 gigabit per second for stationary users and 100 Mbps for high mobility users, we will call that this is our fourth generation. Why so much data rate is required? This data rate is required for like bullet trains. Whenever we are moving with high mobility, we require huge data rate. So in order to meet the requirement of the high mobility services, trains, bullet trains, we require huge data rate. So we set up a target that whenever we require this, we call it as this is a fourth generation. Now we are in third generation. That means we require to move ahead. So after this, we have 3.5G. We call it as this is my HSDPA, which stands for high speed downlink packet access. That means we have focused on the downlink speed because most of the users are downloading. So after that we have an era of cloud computing. That means we have to work with upload speed also. So we have HSUPA 2. HSUPA as high speed uplink packet access. So HSUPA and HSDPA under 3.5G. Now this is giving us around 2 Mbps. We have a target of this. So we have 3 point, after that we move to 3.575G. So with the name of HSPA plus, where plus will represent increased. This is high speed packet access. Now high speed packet access, that means 3.5, and after that we require 4th generation. From this we expected that now we will get 4th generation, but we have 3.9G. We call it as LT, where LT stands for long term evolution. That means evolution for a long term up so that we achieve this, which is what our target is, 4th generation. So they launched 3.9G LT with the name of 4G LT so that we can earn the revenue and we can further use for the development or research of 4th generation. Now we have achieved the 4G targets. That means 4G is successfully launched. We have achieved 1 gigabit per second and 100 Mbps. After that, now we have set a target for 5G. Now this is to be commercial in 2020. Now we have set up a target for 5 gigabit per second. That whenever we are having 5 gigabit per second, we can say that we have 5th generation from 4G. Now we are working that right now we have research and development for the 5th generation. Many companies are working so that we can achieve this data rate, and in 2020 we have commercial 5G networks. So right now the scenario is research and development in 5th generation. We have multiple concepts which is there in the 5th generation to achieve this much data rate. So this is about introduction of technologies, telecom technologies which we have. Now parallelly, that means in 2nd generation, we have another technology also which is CDMA. CDMA as code division multiple access. Now this CDMA is provided by Qualcomm. They have their own patent of the CDMA technology. This technology is prominent in some countries like US. Some countries are using GSM. But CDMA is also there in the 2nd generation. After that, for 3G, we have a concept of this with WCDMA. We call it as wideband code division multiple access. That means we have used the concept of WCDMA in our 3G networks. So this is about introduction of the various telecom technologies. Thank you so much.